All right, there we go. Okay, so here's what we're going to do today. We're going to start chapter 5, like I was talking about, where we've talked about linear functions. Okay, we spent a whole chapter on linear functions, first degree. Now we just spent a whole chapter on quadratics, second degree functions. The next chapter, we're just going up a little bit. We're going up into what third degree and fourth degree, cubic and what are called quartic functions look like. And we're going to start kind of looking at some of those important points. So chapter 4 was all about with quadratics, the vertex, the x-intercepts, the y-intercepts, things like that. If I give you an equation of a quadratic, can you find all the important pieces? Still the same concept, but now we're going to look at cubic and quartic, and we'll go from there, okay? I've got a couple of gifts for you first, a couple of things for you before we get going. First one, I'm going to give you a formula sheet, okay, that you're going to be able to use on the next test, and probably going forward as well. It's got the different equations of lines on it. It's got the quadratic formula. It's got a kind of a summary of semester 1. So let me give you that, and you can use that to, like I said, whether you're working through your homework, whether you're working on your next test, something to guide you a little bit. Ooh. So like I said, if you take a look at it, notice equations of lines. You got the 3 different equations of lines we talked about in our linear chapter. Notice imaginary numbers right next to it. There's the definitions we just talked about from 4.8. Quadratics, it's got the 3 forms. It's got the quadratic formula, okay, things along those lines. The stuff we have not talked about yet are the exponent properties. We have not talked about that at all. That's chapter 6, okay? So we will not get to that this semester. And then we've talked about some of the factoring on the right-hand side, but not all of it. Some of it's coming in chapter 5. So a lot of what we've done is on this sheet, okay? And I'll explain the backside when we get there, okay? We're not going to need it today, but I'll explain why it's on the backside. Again, something to help you out. All right, so that's the first thing I have for you. Second thing I have for you is kind of just a review of semester 1, if you will. But there's a specific reason why I'm giving you this today. It's not necessarily an assignment over break or anything.
We won't have any assignments over break.
Theoretically, let's put it that way. I'm not a huge fan of break assignments. I like you to have a break.
Thank you.
Just like I want a break, I want you guys to have a break too. So this is the reason I'm giving you this. It is a summary, like I said, of kind of first semester. But the reason I'm giving you this is, remember, I told you there's one more test that I'm going to give you this semester. And probably 2/3 of that test will be a review of chapter 4 again. Kind of a repeat where you're going back over it. So the reason, if you go to the back, kind of work from the back instead, and you open up the last 2 pages, that part of this semester review kind of deals with quadratics. So that way, if over break, and again, this is not an assignment, but if over break, you want to kind of keep working on how do I find the vertex? How do I find the x-intercepts? Things along those lines. There's some things here that you can specifically look at and practice, okay? Otherwise, my current plan is the first day you come back, what we're going to do is review quadratics, and then 5.1, we'll go kind of back over that again. It's just a review day once you get back to get things back to being fresh in your mind again. Okay? Because to be honest, when we get back, there's only 3 weeks left of the semester. That's all that's left. And your test will be at the end of the 2nd week. So there's not going to be a whole lot of new stuff. All right, so there's those 2 things. And what I'm going to give you today is I'm going to kind of give you a note sheet so that you're not necessarily taking all the notes on your own. You won't always get this, but I thought today it worked out pretty well so you wouldn't have to copy everything down. So here are the actual notes that we're going to go over today. What I want you to do is try the warm-up in the first box. Do that right now. So do the warm-up, and the warm-up is a review of chapter 4, okay? So it should give you a good idea. So I'll give you a few minutes to do that, and then we'll go from there. And again, if you're not remembering some of this stuff, now use that blue sheet I just gave you. Use your formula sheet to kind of help you out a little bit. All right, I'm going to get into just kind of wherever you're at. If you're not quite finished, that's okay. It's not the end of the world. The last one you may or may not even remember this is like back from grade school, long division. But there's a reason why it's on here, because in chapter 5, there's going to be some long division coming up where there's a long division actually is kind of a process of factoring. It's one of the factoring methods that we're going to talk about. We'll get into that. That's actually next semester. It's not even going to be this semester, but you'll get into that next semester. But here's what you should have come up with. if you went through and you took a look at this. Let me back up here. So -4, -1 is what you should have come up with for the vertex. Okay. Remember, this one is in standard form, so you should have had opposite of b over 2a is where that's coming from. Y-intercept, let me go back to the equation here for a second, make sure you have that. Okay, y-intercept is 15. Remember, you either just plug in 0 and you get 15, or you might have remembered that it is a c value, okay, in a standard form equation. The discriminant, b squared minus 4ac, you should get an answer of 4, which means there's 2 x-intercepts, okay? It also means, because it's a perfect square, that you can factor this to find those x-intercepts, okay? Now, you could still do, you can always do quadratic formula, but because this is a perfect square, you could also factor this one, okay? And you should have found -3 and -5, ignore the complete the square, we didn't do that this year. Or you could have done it, like I said, by quadratic formula. You then sketch the graph. Something we haven't talked a lot about, but I want to just kind of bring it, just as a heads up more than anything. When it says find f at -3, this notation, all this is saying is that's the x coordinate. They're saying find the value of the function at -3. Plug it in and tell me what the y coordinate is. Okay, you're just finding a point. This is notation. That's why I put it on there. So you'd start to understand what this is what's called function notation. So if I plug -3 in and I get an answer, you notice you get 0, because -3 was one of your x-intercepts. If I take f at -5, if I plug -5 into my function and get an answer, the y coordinate is also 0. Okay, so that was that part of it. This, like I said, I mainly left this on because I wanted you to start to see what's called function notation and what they're really asking you. And then, if you remember back to long division, here it is. If you take and actually do the long division, 523 divided by 7, you figure out, all right, 7 goes into 5. Nope, doesn't go in. 7 goes into 52 7 times. Then you multiply. 7 times 7 gives you 49. Then at this point, you go through and you subtract. 52 minus 49 gives you 3. And you bring the 3 down. And you go again. 7 goes into 33 4 times. 4 times 7 is 28. Subtract. And right here is your remainder is 5. And you always put your remainder back over what you're dividing by. So 523 divided by 7 is really 74 and 5/7 is the idea. Okay, you get 74 and 5/7. Again, this is just a preview to something this is coming. This will not be anywhere close to what's on your chapter test coming up. Okay, this is just a, hey, this is coming up in a few sections. Just a heads up to remind you a little bit about this. Okay. All right, let's get into the actual lesson then. So if you take a look, some vocabulary, and you've got it on your note sheet, but just in general, so chapter 5 is what's called polynomial functions. Okay? And we're going to stop at 4th degree, but we're going to look at 3rd and 4th degree functions. So what does that mean? A polynomial is an expression of more than 2 algebraic terms. In other words, the sum of several terms that contain different powers of the same variables. Okay? So a quadratic function is a type of polynomial. A linear function is a type of polynomial. Okay? The degree, here's some of the more important parts. When you look at the degree of a polynomial, we're talking about the largest sum of exponents that are found in the variables within a polynomial. Okay? So for example, a quadratic is a 2nd degree because it's x squared. A linear function, a line, is 1st degree because it's x is raised to the 1st power. That's the highest power. Okay? We're going to look at 3rd degree and 4th degree. That's what we're going to start looking at. Okay? So that's when we talk about the degree of a polynomial, that's going to come into play quite a bit in this chapter. So like we said, quadratics have degree 2, lines have degree 1. Here's something we're going to introduce that we haven't talked a lot about, but the idea of what's end behavior is what this is called, describing the behavior of a function as it approaches negative or positive infinity. Here's why that's important as you analyze a function, okay? Remember, we said one of the main ideas of why we do all the stuff we do is so that we can make a prediction. In the future, in the past, that's what end behavior is doing. We're saying as x gets really, really, really big, as x goes into the future, what happens to y? Is it getting really big? Is it getting really small? Is it approaching a number? What's going on? Or as x goes to negative infinity. If we go way back into the past, what's happening to y? Was it way up there? Was it way down there? Where is it? Okay, and we'll get into some problems to take a look at that. But that's this idea is we're looking at the two ends of the graph, positive and negative infinity. Okay, and then the last part, zeros, roots, x-intercepts, these are all kind of the same thing. The zeros of a function are the x-intercepts. Okay, some are real, some might be imaginary. We talked about that coming up. We'll look at that in this chapter. X-intercepts, zeros, roots, these are all solutions. These are all names for the same thing. Okay, they're used in different scenarios, but they basically mean all the same thing. Okay, so just a heads up, if you see zeros, I'm talking about an x-intercept. If you talk about roots, I'm talking about x-intercepts. Okay, so just some background information for you on that one. All right, so here's some review. Here's what we need to talk about. This is the kind of the first thing we got to take a look at. So a monomial, mono meaning one, okay, is an expression which is a number, variable, or product of the two, but it's only one term. You're not adding or subtracting anything to it. Okay? X squared would be an example of a monomial. Not x squared plus 5. Now you're adding or subtracting. So terms are always separated by plus or minus signs. Okay? The coefficient, we've used this term a lot. Coefficient's always just a number in front of the variable. That's like our a value, our b value, our c value. Those were all coefficients. Okay. The degree we already talked about. It's the sum of the exponents of the variable. We're getting into that. And if we keep going, just a little practice here. So here's my monomial. Notice nothing added or subtracted, just the letter p. Okay. What's the coefficient on p? 1. Yeah, technically there's a 1 sitting in front there. So my coefficient is 1. What's the degree? What power is this raised to? If it's not written, what is it?
1.
First power. Yep. P to the first power is just p. Okay? So if I were going to go through and name this, and we'll talk about naming on the next slide, this is a linear, because it's degree 1, monomial. Okay? Because there's only one term. It's a linear monomial. We'll talk about that. This one. What's the coefficient? -3. That's what's in front of the a. And what's the degree? What power is a raised to? First power again. Okay. So this is another linear function. Okay. If I came to this one gets a little bit trickier, but what's the coefficient on this one? That's the fourth. It's sitting out front. Okay. And I say this one's a little bit trickier because we got multiple variables, but what's the total degree of all the variables? 3. I have 2 a's and 1 b for a total of 3. So this is a third degree monomial. Okay, notice again, I keep saying monomial because we're not adding or subtracting anything to this. Okay. Let me give you one more. Actually, we'll give you 2 more because I want to talk about that one too. What's the coefficient of that?
1.
There's a 1 sitting out front again. Yep. And what's the degree on this one?
6.
Good. 2 x's, 3 y's, and 1 z. Total of 6. And the last one I want to actually go over, which is the last one here. What's the coefficient? It is the 5. Okay. What's the degree? This one's tricky. That's why I wanted to talk about this one.
There's no letters.
Which means what's the degree?
0.
0. This is a 0 degree because there is no letters. This is what's just called a constant. Like the c value that's always in your quadratics we've been talking about, that's a constant. Okay, so this is a constant monomial. There's no variable to make it go up or down. It always is 5. Okay, so here's really what I want you to get out of this. Okay, we're going to start naming these polynomials so that we know just the vocabulary. When I give you a problem, you know what we're working with, so we can kind of communicate that way. So if I have a degree of 0, like that 5, we just said, that is what's called a constant. Okay. It doesn't go up, it doesn't go down, it is just a number. Okay, constant. All first degree functions, we said, are what? Lines, they are linear. Okay. When you graph a first degree function, it looks like a line, so it is linear. We just finished a chapter on second degree functions. What are they? Quadratic. Yep. Those are quadratic functions. How about 3? What happens when you raise something to the third power? What do you do with it? What's that called? You don't square it, you cube it. So this is called a cubic function. Okay? Third degree functions are called cubic functions. What about fourth degree? This one you may or may not know. I said it earlier, but you may not have picked up on it.
Quad. I don't know.
Think about like a game. You got 4 quarters in a game. You got 4 quarts in a gallon, something along those lines. So no, I'll continue. I don't want that to end. There we go. So this is what's called quartic. Okay, that is called a quartic function. Okay. And 5, we could go to 5. It's technically, if you think of like if somebody ever has like five babies at the same time, they have quintuplets. This is a quintic function. But anything bigger than 4, we're going to kind of stop at 4 for this chapter. We're not going to go into 5 and 6 and 7 and all that kind of stuff. Okay. So the second part of this is how many terms do I have? Okay, we're going to put this together. We already talked about number 1. If there's only one term, it is called a monomial. Okay. Mono meaning 1. If it is 2 terms, like x plus 5, what do you think 2 terms is called? That's a binomial. Okay, bi meaning 2. And therefore, what do you think 3 terms is called? That is a trinomial. Okay. And 4 or more, you just use the number. It's a quadratic 4-term polynomial, 5-term polynomial. You just use the number. There's no specific name. Okay? That's what I'm going to put down. There's no specific name. You just use the number. You just say there's 7 terms, 8 terms, whatever it is, 5 terms. Okay? So just like you have a first and a last name, so do polynomials. Okay? Based on their degree and number of terms. So I could have a quadratic binomial, a quadratic function that only has 2 terms in it. I could have a quadratic trinomial. Okay, those are the types where, like a standard form equation that's got a, b, and c. That's a quadratic trinomial. You could have a linear monomial, x or 2x. That's a linear first degree monomial, 1 term. Okay, so there's different ways of looking at these types of problems. Okay, so if we take a look, let's do a few examples here together. First question: what's the highest degree? Okay, now I cannot combine those. Okay, keep in mind I can't combine these because I have x's, x squareds, and x cubes. They're not the same, so I got to keep them separate. What's the highest degree of the terms? 3, right? So this is cubic. How many terms do I have? 3. I've got the 3x squared, the 2x cubed, and the 4x. So this is what's called a cubic trinomial. That is what is called a cubic trinomial. Cubic because the highest degree is 3. Trinomial because you have 3 terms. Remember, terms are always separated by plus and minus signs. So here's 1, 2, 3. How about the next one? What degree? 4th degree, that's the highest power we have. So this is a quartic. How many terms? Trinomial. Yep, there's 1, 2, and 3. That is a quartic trinomial. And well, one of the things we're going to talk about today is what does a quartic graph look like? We know that all quadratics look like parabolas. They either open up or down. We know that all lines, okay, all linear functions look like lines. What does a cubic function look like? What does a quartic function look like? We'll get to that. Okay. What about this last one, example 3 here? This one's a little bit different. Highest degree. It looks messier, but don't let that confuse you. Still a 4th degree, right? Still the highest power is to the 4th power. So this is still quartic. How many terms? Still 3, yep. You got the negative x, you've got the 1 with the x to the 4th. There's your 3 terms. So this is still a quartic trinomial. It just has some messier numbers on it. That's all. The coefficients are a little bit, especially the square root of 5 is a little messier. So these are the types of problems we're going to look at. I told you this is kind of an introduction to the chapter. Okay? So now if we take a look, here's the main idea for today. Okay? Being able to take a look, if I talk about linear, quadratic, cubic, quartic, I want you to be able to tell me what's the general shape of the graph. Okay? So let's start with the 2 that we already have worked with. And I'm going to break each one of these into 2 parts. Okay, because there's the degree and one other thing tells me whether or not what this looks like. We said linear functions look like lines, okay? But generally, the equation I'm going to give, normally you do y equals mx plus b. I'm going to change the m to an a. I'm going to call it y equals ax plus b just so it fits with everything else. What that means is if a is positive, you have a line that's increasing. If a is negative, if you have a slope that is negative, then you have a line that is decreasing. Okay? So if you just take m out and put an a in that spot instead, it'll make some more sense. When we get to a quadratic, what's the difference between if a is positive versus negative? What did we talk about last chapter? If a is positive, what does this look like?
Goes down. Goes up. Or,
If
yeah.
a is positive, it's a parabola that's opening up. If a is negative, then it opens down. So what I'm getting at is there's kind of two parts. Not only does the degree determines the shape, the a value also has an effect on what goes on with the graph, okay? So the degree and the a value kind of go together. So now let's take a look at the bottom two. Here's our new stuff. A third degree function, okay, a cubic. The general form, by the way, standard form of a cubic, y equals ax cubed plus bx squared plus cx plus d. Okay, you just keep adding things to that. Same thing again, though. Matters whether a is positive or negative. So our third degree function, our cubic, anybody know what it looks like out of curiosity? Anybody have any idea? I call this one like the roller coaster of things. If a is positive, it starts down low, comes up, back down, back up again. There's your roller coaster. If a is negative, it is just generally decreasing instead of increasing. Instead of starting down low and then increasing, you start up high and still kind of the same exact roller coaster, except it's decreasing as you go from left to right. Okay? That's kind of the general shape of a cubic. What I want you to notice, by the way, and we're going to talk about this more specifically, but for now, what I also want you to notice is odd degree functions. When we get into this idea of end behavior, kind of have the same idea. A is positive, A is positive. Notice I'm starting kind of down low, and it's generally increasing. Same idea. I'm starting down low, and there's still a general increase to this. Yeah, there's a little bit of a change of direction in there, but it's still a general increase. Here's a general decrease. There's a general decrease. Okay? So we're going to get into that. We're gonna kind of talk about that a little bit more specifically. For now, I just want you to notice. All right, let's take a look here with quartic. Anybody have any idea what quartic functions look like? Two different letters. Again, let me put the equation down. Y equals ax to the fourth, bx cubed, cx squared, dx plus e. Okay, you just keep adding letters. And again, if a is positive versus a being negative. Ooh, sorry. Looks like a W. What do you think it looks like if a is negative? Yep, just flips, just a reflection. It looks like an M instead. So I told you before, kind of like a linear and cubic kind of act the same. Same idea with fourth degree and second degree. This is either opening up versus opening down, just like a parabola. Okay? So even degrees kind of act the same way. Here's one other thing I want you to notice, just as a general idea. The degree matches up with the number of changes of direction. Here's what I mean by that. This is a fourth degree. Going down is one direction, then it changes, there's direction 2, there's direction 3, and then it goes back up direction number 4. Fourth degree, 4 different directions. If you look at a cubic, 1, we're going down, 2 comes back up, 3 goes back down. Third degree, 3 directions. Think back to stuff we've already done. We didn't put this together at the time because we didn't really need to, but even a quadratic goes down and then back up, 2 different directions. Linear functions, increasing or just decreasing, 1 direction, first degree. So the degree tells you kind of what the general shape of the graph will end up looking like. So that's another piece to kind of put together with that. Let me stop for a second. Any questions on this specific slide? Because what we're trying to build right now is at least just the general idea of what does a third degree function look like depending on your a value? What does a fourth degree function look like depending on the a value? Okay, so if we keep going, here's where we now add end behavior. Okay, and this is the last idea. This is the last concept for this lesson. So if we take a look, end behavior is which direction the graph is going, whether it rises or falls. We talked about that. Odd functions start in one end and kind of either increase or opposite, and one or the other. Even functions always start and end in the same spot, like a parabola. Opening up, opening up. Both ends are pointing up. Or it opens down. Both ends are pointing down. The leading coefficient test, that's the a value that I was talking about. The leading coefficient test and the degree determine the end behavior. Okay? So basically, the degree determines the shape. The a value determines whether it's opening up versus opening down, whether it's increasing versus decreasing. Okay? And that's what we were just doing just now as we were sketching those. A value and degree, that's what that says. And the end behavior is determined by the highest degree and its coefficient. We kind of talked about that. It's a little bit repetitive. That kind of says the same thing. So let's take a look. Here's kind of your summary of things. Even degree polynomials, quadratics, and like we said, parabolas, W versus M, will always start and end in the same spot. If you're opening up, they're both going up to infinity. If it's opening down, they both go to negative infinity. Odd degrees will always start and end in opposite spots. Okay? Like a line, we said, if it starts down low, it ends up high. Starts at negative infinity, ends at positive infinity. Or the other way around. Starts at positive infinity and decreases to negative infinity. But they'll always start and end in 2 different spots. How to remember. And I kind of brought this up already. Odd functions act like lines, meaning they're generally increasing or generally decreasing. Even if it's a cubic, we say, well, yeah, there's a little change of direction, but then it goes back up and is increasing again. Or change of direction and then it goes back down, okay? So here's kind of the general idea. Let me show you everything and I'll explain it. I'll interpret here for you. So we kind of already talked about positive slope, general increase, general decrease. We talked about that. Here's the part I want to make sure you understand. This is the notation that we're going to use. This is our end behavior notation. So what this says is as x goes to negative infinity, meaning, and I'm just going to use this person's arm here, if this was the graph, as x is going to negative infinity, where is y going? Where's the graph going? Oh, as we're going, let me think of this as like a line right here. Okay, if that's my line, as we go negative, where's the line going? Is it going up or is it going down? Going down, right? That's what this says right here. As x goes to negative infinity, as we work towards the left side of the graph, the y values are going down, they're decreasing. This talks about the other end of the graph. As x goes to positive infinity, okay, meaning as we're going that way on the graph, where are the y values? Are the y values getting bigger or smaller? X gets bigger, what's happening to y? Are we going up or are we going down? We're going up. The y values are increasing. That is what this says. Okay? So all we're doing is we're looking at it's called end behavior because we're looking at the two ends of the graph. One end of the graph is decreasing, is going down. The other end of the graph is going up. But this is the notation. And you don't necessarily have to use the f of x notation. You can just, instead of putting that in here, you can put this as y. Okay? We don't have to worry about that for now. We'll just call that y. As x goes to negative infinity, y goes to negative infinity. We are decreasing. If we take a look at this one, for example, if this is my line, if I were going to graph that, as x is going to negative infinity, where's that line going? Is it going up or down? As I work my way this way, where's the line going? That's going up, right? That's what this says. As x goes to negative infinity, y is increasing up to positive infinity. The other end of the graph, as x is going to positive infinity, as x is getting bigger and bigger and bigger, as we go to the right side of the graph, what's happening to the y values? Are they going up or are they going down? Going down. That is what this says right here. As x goes to either positive or negative infinity, what happens to y? That's the end behavior. What's that? Say that again? Oh, you didn't draw that, yep. There. So as x is getting bigger, y is getting smaller. As x is getting smaller, y is getting bigger. Okay? And if we took a look at that same idea down here on the parabola portion, or like the w versus the m, it's the same idea. Okay? If we take a look, and let's say this was a parabola. There's my parabola right there. As x goes to negative infinity, what's happening to y? Where are we going? Up. Going to infinity. As x goes to positive infinity, as x gets bigger, what's happening to y? Up. Up. And that's what this is saying down here. This is just the way to write what we just said. Okay, this is the mathematical way to write it. So general main idea of this lesson is, can you name functions, okay, linear, cubic, whatever, monomial, binomial, trinomial? Can you have an idea, general idea of what the graph is going to look like? And can we add in this concept of end behavior? That's kind of the three parts to this lesson. That's what you want to be able to get out of. Those are some of the things we're going to look at as we move into the chapter. Okay? So if we take a look, let's just do a couple of these together here. Let's talk about this. We'll do some practice problems. Okay, so first off, if this is I want to talk about let's actually kind of put it all together. Even though it says determine the end behavior, let's take these problems and kind of just put those three things together that I just said. If you were going to name this function, what would you name it? That's a quartic trinomial. Let's start there. Quartic, because it's fourth degree. Trinomial, because it has three terms. All right. Next up, if you were going to sketch this graph, generally, what would this look like? What shape? It'd be a W. Okay? When it's a fourth degree, it's always going to either be a W or an M. It's a W because A is positive, so it's opening up. So I know the general shape of the graph will be something like that. So now let's use that general shape to write our end behavior. Okay? So as x goes to negative infinity, we got to figure out where y goes. So as x is going to negative infinity, where's my y value going? Up or down? Up, which means y is going to positive infinity. As x goes to positive infinity, if we now start looking at the other end of the graph, as x is going to positive infinity, where's the graph go? Positive infinity, it goes up. Okay? Right there is basically a summary of this entire lesson. Can you name this? Can you have an idea of what this looks like? And can we figure out kind of what's happening on the ends of the graph? Okay? Let's do another one. Let's put this one together as well. What would we call this one? This is a cubic trinomial. Okay. There's the first part. Monomial. There we go. Okay, what would this one look like? General shape.
What would we even like describe that as?
I call it the roller coaster.
Okay.
Just because you're kind of going up, back, down, you're kind of, so it's the roller coaster now. Let me ask you this. Does this roller coaster start down low and end up high? Or does it start high and end low? Because A is negative, that means we start high and we're ending low. Which also is kind of describing your end behavior. As x goes to negative infinity, I'm going to put them both down right away. So as x is going to negative infinity, where's y go? Up. We start up here at positive infinity. And where do we end? Starting up here at positive infinity, and where's the other end of the graph ending? Going down to negative infinity. We start up high, we end down low. Up high is positive infinity, down low is negative infinity. Let me stop for a second. How are we doing on this stuff? Is this making sense? You getting the general idea at least? Because like I said, this is really the main idea of today, right here in 2 problems. This is the main thing I want you to be able to do out of today's lesson. Okay? I gave you one more challenge problem. Out of curiosity, we didn't talk about what a 5th degree function looks like. Any idea? No? Here's the key part. It's 5th degree, and the a value is positive, right? Kinda. You have the right idea. You're off a little bit, but you have the right idea. Because it's an odd degree, we know it's either going to start high and end low, similar to like what we just did. Okay? Or the other way around. This time, because the a value is positive, I know I'm generally increasing. Here's the idea. Because it's a 5th degree, that means I've got 5 different directions. 1, 2, 3, 4, 5. There would be a rough sketch of what this could look like. Up, down, up, down, up. 5 directions, 5th degree. And the end behavior for this one? As x goes to negative infinity, and then as x goes to positive infinity. What's happening on the 2 ends of the graph? Where do I start? As x goes to negative infinity, where's the graph going?
Down.
Down, negative infinity. As x goes to positive infinity, where's the graph going? Up. Remember, odds always start and end in 2 different spots. Starting at negative infinity and ending at positive infinity. Okay? The challenge part of this was recognizing the 5 different changes of directions. How we doing? Okay. So, what I have for you is this, and only because I already did this. When I made these, originally when I made copies and when I was going through and I was doing this, I was going to kind of give you a different lesson. I was going to combine the first 2 sections lesson and then give you plenty of time to work on it over a couple of days. So when I made copies, I stapled together the first 2 worksheets. So I'm still going to give you those. You're only responsible for the first worksheet. Okay? Just the 5-1. You don't have to do the 5-2 yet. We'll talk about that after break. We'll take care of that. So let me give you that. This is this is the one thing. And this is where when you had asked me earlier, like, am I going to have homework over break? Here's what I was referring to when I said me.
And we're only doing 5-1, right?
Yes, the only thing you have to do here is the 5-1 worksheet, which is pretty much exactly what we just did. Okay? By the way, on the first set of sections, when they say write it in standard form, they mean just put it in order. So the highest degree is first, then the next highest degree, then the next, so it goes down in order. Just rearrange the terms.
Do you want us
Okay.
to put y equals, or does it matter?
No, you're okay. You can, but you don't have to. So just the 5-1 worksheet. And when I said before, would you have any, this is technically due by the time you get back, okay, from break. But when I said that are you technically going to have any homework over break? If it were me, personally, I would do this either today or tomorrow, and then you don't have to worry about it. I'm not giving you anything else to do, okay? So I would get this done either today or tomorrow. It shouldn't take you very long, and then have a good break. Take the time and rest and relaxation and enjoy the time off. Okay? You do still have 5-7 minutes somewhere in there. I'm not going to quite let you go yet, but I will let you go early again today. And like I said, when we get back, we'll recap chapter 4, and we'll kind of recap this lesson again as well, just to refresh you. You can call it Quinte. Or even if you just said fifth degree. Yeah.